So guys, now we start the next topic of application of derivative, which is approximation. Here, the second part of application of derivative is approximation. What is the exact meaning of approximation? What is the exact value of approximate value? So here it is clear that we know about the value of under root 4 is 2, but we don't know about the value of under root 4.00001 is equal to. If we have to find the value of this under root of 4.00001, then we use the rules of approximation. By using the rules of approximation, we can find the value of these completed expressions. So it is clear that we know that under root 9 is equal to 3, but we don't know about under root of 9.02. If we have to find the value of under root 9.02, then we can use the rules of approximation. Then what is approximation? Approximate means nearer value. Here we can't find the exact square root of 9.00. The exact square value of the square root, which is 9, is 3, but we can't find the exact value of 9.02. Hence, here we have to find the approximate value of square root of 9.02. So we know about approximation. What is approximation? Approximation, if f is differentiable function, if f is differentiable function of x, then its derivative at x is equals to a is f dash of a is equals to limit h tends to 0 f of a plus h minus f of a upon h. Here the derivative of f of a or derivative of f of x at x is equals to a is f dash of a is equals to limit h tends to 0 f of a plus h minus f of a upon h. Here h is very small increment. Here h is very small increment in a plus h. It means that the value of a plus h is approximate to a. Hence, here we use the approximate value, which is the sign which is approximate value, approximate sign. Hence, here if we apply the approximate sign, we can write f dash of a is equals to limit means approximate. So here if we use the approximate sign, then limit will be removed, and we can write f of a plus h minus f of a upon h. So if we take this h left side, the divider h become multiplied function h into f dash of a is approximate to f of a plus h minus f of a. This minus f of a, if we shift left side, minus become plus, we can write minus f of a plus h into f dash of a is approximate to f of a plus h. Hence we can write f of a plus h is approximate to f of a plus h into f dash of a, which is the rules of approximation. This rule we can also call as rules of approximation. By using these rules of approximation, we can find the value of, for example, under root of 4.001, for example, under root of 9.02, and many more for as follows. So the first example of approximation, which is related to rules of approximation, here The example number first is find the approximate value of, and the given value is under root of 64.1. We know that the under root of 64 is 8. But here it is difficult to find that under root of 64.1 is equals to what? So here the function which is in under root, we can consider that the root is f and a plus h. If we consider this 61.1 which is a plus h, we can separate it. A is 64 and h is 0.1 because h is a very small increment. So by using rules of approximation, we know about the rules of approximation. The rules of approximation is f of a plus h is approximate to f of a plus h into f dash of a. So it is clear that if we have to find the value of f of a plus h, then first we know about f of a and the value of f dash of a. So the function which is in the form of f of x, by using this function we can find at x is equals to a f of a, and after differentiating f dash of a. So first we consider that let whole function f of x is equals to, which is in the form of x is under root x, which is equation number 1. By applying this equation, if we differentiate with respect to x, then we can write derivative of f of x, which is f dash of x 1 upon 2 root x number 2. So here f of x and f dash of x at x is equals to a, we can also write f of a is equals to under root a and f dash of x is equals to 1 upon 2 root x. So first we know about 64.1. Let us consider that function 64.1 is a plus h is equals to 64.1. So here we can consider a is equals to 64 and h is equals to 0.1. 64 plus 0.1 is 64.1. By using this value of a, we can write f of a is equals to, replacing the value of a which is f of 64, which is f of 64 means under root of 64 and the under root of 64 is 8. So again f dash of a is equals to f dash of 64 is equals to 1 upon 2 under root of x means again a, and the value of a which is 64 means 1 upon 2 into under root a, 64 is 8 means 1 upon 16. So we know that by using the rules of approximation, we can write f of a plus h is approximate to f of a plus h into f dash of a. We know about the value of f of a is 8, h is 0.1, f dash of a is 1 by 16. So f of a plus h means whole function f of x is under root of 64.1. The value of under root of 64.1 is approximate to f of a means 8 plus h means 0.1 into 1 upon 16. The value of 1 upon 16 is 0.0625. Hence we can write under root of 64.1 is approximate to 8 plus 0.0625 into 0.1. So if we multiply this both term 0.1 into 0.0625, the multiplication or product of this term is 8 plus 0.00625. If we take addition of this both term, we can write 8.00625, which is approximate or required value of 64.1. So the next example number 2, which is find the approximate value of 3.98 whole bracket cubic. Here the given function is 3.98 whole bracket cube. Here we have to find the value of 3.98 bracket cube. Let us consider that the function f of x is, which is in the form of a plus h, is x whole bracket cube. It means that the value of 3.98 we consider that x, and we know that x is equals to a plus h here, and the value of a plus h is equals to 3.98. It is possible to that we have to find the value of 4 cube, which is 64, but here it is difficult to find the value of 3.98 whole bracket cube. The distance between 3.98 and 4 is very approximate distance. Hence, if we write this 3.98 in form of 4 minus 0.02, the value of 4 minus 0.02, which is 3.98, we can consider that value of x or a plus h. Here a is 4 and h is minus 0.02, which is approximate value. So first we consider that f of x is equals to x cube. If we differentiate the given function with respect to x, the derivative of f of x, which is f dash of x, and the derivative of x cube is 3x square, which is number 1. Number second, now we know that now x is equals to 3.98. X is equals to means a plus h is equals to 3.98, and we can write this 3.98 is 4 minus 0.02, or we can write it a plus h is equals to 4 plus minus 0.02. So here a is equals to 4 and the value of h is equals to minus 0.02. Both value of a plus a and h minus 0.02 we can find first. At x is equals to a, f of a, the value of f of a or value of f of 4 is equals to 4 cube, which is 64, and f dash of a is equals to f dash of 4, which is 3 into 4 square. 3 into 4 square means 16, which is 48. So by the rules of approximation, the rules of approximation is f of a plus h is approximate to f of a plus h into f dash of a is equals to the value of f of a plus h, which is 3.98 bracket cube, is approximate to f of a, which is the value of f of a is 64, plus the value of h is, which is very small increment, minus 0.02 into f dash of a means 48. The product of 0.02 and 48 is approximate to 64 plus 0.96. If we sum this 64 and 0.96, we can write 64.96, which is approximate value of 3.98 whole bracket cube. It means that the required value of 3.98 bracket cube, which is approximate to 64.96. Sorry, here the value of h, which is minus 0.02, minus 0.02, here minus 0.02, minus 96 means 64 minus 0.96 is 63.04, which is the required value. So the next example number 3 again, find the approximate value of sine of 30 degree 30 minutes. and the given criteria is 1 degree is equals to 0.0175 Celsius and cos of 30 degree is equals to 0.866. Here the degree which is converted into Celsius, which is 1 degree is equals to 0.0175, which is a real value. First we know that degree, 1 degree is equals to 60 minutes and 1 minute is equals to 60 seconds. If we have to convert any value which is in minute into degree, then if we divide 60 minutes, then we can convert this value in a degree. So hence we can write if or what is 30 minutes in degree. We know that 1 degree is equals to 60 minutes. So we have to find the value of 30 minutes. If we divide 30 by 60, then we get 30 upon 60, which is this 30 minute is in form of a degree. So we can write 30 is 162, 1 by 2 degree is the value of 30 minutes. Now first we consider that let f of x is equals to sin x. Here x is equals to a plus h and a plus h is 30 degree, 30 minutes. If we differentiate with respect to x, then the derivative of f of x, which is f dash of x, is equals to derivative of sin x, which is cos x. Number 1, number 2. Now we know that the value of a plus h. So the value of a plus h is 30 degree, 30 minutes, means a is equals to 30 degree and h is equals to 30 minute, means half a degree. Here we can find also 1 degree is equals to 0.0175, means also we can write the value of h in the radian 0.0175 upon 2, the value of h. It means that the value of a is 30 degree and the value of h is 0.0175 upon 2. Now first we know about the value of f of a, means f of 30 degree. The value of f of x is sin x. Value of f of a is sin a, and the value of f of 30 is sin 30. And you know very well about the value of sin 30 degree is equals to the value of sin 30 degree, means sin of pi by 6 is equals to 1 by 2. Or we can write it 0.5. So again the value of f dash of a is equals to f dash of 30 degree and f dash of a is equals to, we know that f dash of 30 degree is a is equals to 30 degree, which is cos of 30, and the cos of 30 degree is given 0.866. So now we can apply the rules of approximation. By the rules of approximation, f of a plus h is approximate to f of a plus h into f dash of a. So here the value of f of a plus h, which is approximate to f of a plus h into f dash of a, is whole value of f of a plus h is sin of 30 degree 30 minute, is approximate to the value of f of a, which is the value of f of a, which is 0.5 plus h is very small increment, which is 0.0175 upon 2 into the value of f dash of a. Value of f dash of a is 0.866. If we divide this 0.866, we can write 0.5 plus 0.0175 2's 1 0.433 into 0.433. So product of 0.5 plus 0.175 into 0.433 0.075775. If we take addition of this both term, we can write the approximate value of sin 30 degree 30 minute is 0.575775, which is the required value of the given function. So the next example, which is example number 4, find the approximate value of tan inverse of 0.99. Here given that pi is approximate to 3.1416. Let function f of x is equals to tan inverse of x. So if we differentiate given function with respect to x, then we get derivative of f of x is f dash of x, and the derivative of tan inverse x is 1 upon 1 plus x square. It is clear that x replaced by 0.99. So hence we can consider that here a plus h is equals to 0.99. This 0.99 we can write 1 minus 0.1 or 1 minus 0.01. It means that a plus h is equals to 1 plus minus 0.01. So here therefore a is equals to 1 and h is equals to minus 0.01. The value of a is 1 and the value of h, which is minus 0.01. So from above condition we can find the value of f of a at x is equals to a and a is equals to 1. The value of f of 1 also we can write tan inverse 1. We know that the value of tan inverse pi by 4, tan of pi by 4 is 1. Hence the value of tan inverse 1, which is pi by 4. Again, the value of f dash of a is equals to, the value of f dash of a is 1 upon 1 plus x square, or value of f dash of 1 is equals to 1 upon 1 plus x square, means 1 upon 1 plus 1 square. 1 plus 1 square which is 1, 1 plus 1 which is 1 by 2, or we can write 0.5. But we have to find the approximate value of tan inverse of 0.99 by using the rules of approximation. By using the rules of approximation, we can write f of a plus h is approximate to f of a plus h into f dash of a. The value of f of a plus h means the value of tan inverse of 0.99 is approximate to, or we can write f of a is pi by 4 plus h is very close value or approximate value, which is minus 0.01, and the value of f dash of a, which is 1 by 2, or we can write this value 0.05. Hence we can write pi by 4 plus or minus 0.01 into 0.5. So 0.01 into 0.5 is approximate to pi by 4 minus 0.005. Again the value of pi is given, which is 3.1416 upon 4 minus 0.05, and the whole calculation of 3 minus 1416 upon 4 minus 0.05 is 0.7804, which is approximate value of tan inverse of 0.99, which is a required approximate value. So the next example number 5, and here again we have to find the approximate value of e raised to the power 1.005, and it is given the value of e, which is 2.7183. So first we consider that given function f of x is equals to e raised to the power 1.005. 1.005, or let f of x is equals to e to the power x, hence the value of x, which is 1.005. If we differentiate with respect to x, then we get the value of f of x, which is f dash of x, and the value derivative of e to the power x is also e to the power x, which is number 1, number 2. X is equals to a plus h, and the value of a plus h is 1.005. By distributing, we can say that a is equals to 1 plus 0.005, means a is equals to 1 and h is equals to 0.005. Now from the above condition we can find the value of f of a or the value of f of 1, which is e to the power 1, which is e, and the value of f dash of a, which is f dash of 1, is equals to e to the power 1, which is also e. Then if we have to find the value of e to the power 1.005, then we can use the rules of approximation. Therefore, by the definition or by the rules of approximation, we can write f of a plus h is approximate to f of a plus h into f dash of a. So the value of f of a, which is e, plus h is very small increment, is 0.005. Again the value of f dash of a is e. If we take e common from both term, we can write 1 plus 0.005. Here approximate to the value of e is given, which is 2.7183 into 1 plus 0.005 is 1.005. The product of both term, which is 2.7183 into 1.005, is 2.73189. 2.73189, which is the approximate value of e raised to the power 1.005. So here again example number 6, and we have to find the approximate value, but the given function is in the form of logarithmic function, and the logarithmic function given function, which is log base 10 998. So here given value log base 10 is equals to 0.4343. First, if we have to find the value of log base 10 of 998, first we consider that f of x is equals to log base 10 of x. If we differentiate, or we can write this f of x is equals to log of x upon log base 10 e, or we can write this f of x is equals to, if we shift this log base 10 in numerator, we can write the log base 10e into log x, which is number 1. If we differentiate with respect to x, the derivative of f of x, which is f dash of x, is equals to derivative of f of x, f dash of x is equals to log base 10 is constant and the derivative of log of x, which is 1 by x, number 2. So we know that here a is equals to a plus h, or x is equals to 998. We can write this 998 is also 1000 minus 2. It is clear that a is equals to 1000 and h is equals to minus 2. So the value of a 1000 and the value of h is minus 2. From the above condition, we can find the value of f of a is equals to, f of a means log base 10e, log base 10e into value of log x, means value of log of 1000. Log of 1000. We know about the value of log of 1000, which is given. So this log base 10 we can write log base 10, log of 1000 means 10 cube upon log 10, or we can write this log 3 log base 10 of 10. The value of log base 10 of 10, which is 1, 3 into 1, 3. After that, we have to find the value of f dash of a. F dash of a is equals to the value of f dash of a, which is f dash of a is equals to log base 10e, log base 10e into 1 upon a, means 1 upon the value of a is 1000. So we know that the value of log base 10 is 0.4343, 0.4343 upon 1000. We can write the value of f of a is 0.004343, which is the value of f dash of a. So here, by using the rules of approximation, we can find f of a plus h is approximate to f of a plus h into f dash of a. It means that log base 10 998 is the value of f of a is 3 plus the value of h, which is minus 2, into the value of f dash of a is 0.00043343. So we can write 3 plus minus minus my 2 into 0.333, 0.0008686. If we subtract 0.0008686 from 3, then we get the final answer 2.9991314, 2.9991314, which is the required value of log base 10 998. So the next, which is example number 7, is find the approximate value of f of x is equals to x cube plus 5x square minus 2x plus 3 at x is equals to 1.98. Here we have to find the value of approximate value of x cube plus 5x square minus 2x plus 3. So first we take f of x is equals to x cube plus 5x square minus 2x plus 3 is a given. If we differentiate with respect to x, given that with respect to x, we can write derivative of f of x, which is f dash of x, derivative of x cube, which is 3x square, plus 5 to derivative of x square, which is 2x, minus 2 into derivative of x is 1, plus derivative of 3 is 0. Here we can write 3x square means derivative of 3x square, which is 6x, plus 5 into 2 10x, minus 2 into 1, which is 2. Here the value of f dash of x, which is f of x 1, f dash of x 2. We know that here x is equals to 1.98, means x is equals to a plus h is equals to 1.98. We can write this 1.98 is 2 minus 0.01 or 2 plus minus 0.98 means 0.02. Therefore, the value of a is 2 and the value of h is minus 0.02. From the above condition, we can find the value of f of a is equals to f of a means the value of f of 2, which is a 2 cube, by using x is equals to a at x is 2, bar plus 5 into 2 square minus 2 into 2 plus 3, 2 cube which is 8 plus 5 into 4, 20 minus 4 plus 3. So 28 minus 1, which is a 27, the value of f of a. Also the value of f dash of a is equals to 6 into 2 square plus 10 into 2 minus 2. 6 into 2 square 4 plus 20 minus 2, 24 plus 20 minus 2, which is 44. 6 into 2 square, not a 6x square, which is 3x square, means here 3 into 2 square, 3 into 4, which is a 12 plus 20, 32 minus 2, the value of f dash of a is 30. Therefore, by the rules of approximation, we can write f of a plus h is approximate to f of a plus h into f dash of a. So here the value of f of a is 27 plus h is minus 0.02 into f dash of a is 30. So we can write 27 minus 0.30 into 2, which is 60. So we can write the value of approximate 26 minus 26.40, which is the approximate value of f of x or f of a plus h, which is the required approximate value 26.40.